Okay, so somebody give me a thumbs up. Can you all see that?
Yep.
Yep. Excellent. Okay. Right. Well, good evening. What I was going to suggest is if anybody has a question during the talk, you can do one of three things. The first thing is you can keep your question to yourself. No, that's not one of the three things. There's two things really. You can either wait till the end and ask your question, or if you want to, just unmute your mic and shout out, and I will try and answer your question.
Just for anybody that doesn't know, if you're on mute and you want to temporarily unmute it, you just press the space bar.
Thank you. I didn't know that, so that's there we are. God, it's always good having somebody in the chat room who knows what they're doing. Okay. So this talk, I'm giving this talk twice this week. I'm doing this talk again on Tuesday night for Gary Linton's club. So this is my dress rehearsal for the talk. Well, I think this is a talk I did a few years ago, and it's based around basically where we all live. I think 80% of the world's population live in towns and cities, and that brings a number of unique challenges for doing astronomy, some of which I'm sure people are aware of. But this talk's kind of taken on a bit more significance this year with the lockdown and everything that's gone on. Certainly in the early phases of lockdown, we weren't allowed to travel, and the travelling we've been allowed to do has been limited. Certainly, I know I've missed immensely the sort of social side of observing. I know I've been posting a lot of images lately on the Society's Facebook page, but I do not regard myself as an imager. I'm a visual observer, always have been primarily, and this is an activity which I love to do with other people. I love getting together in a group and observing the sky, and it's been difficult, but as we'll see, we've muddled through. Okie dokie. So, what does a star camp look like during COVID lockdown? It looks a little bit like this for me. I've had to resort to dragging members of my family to become my sort of my social sort of bubble for observing, and my daughter and my son and my wife have all been unfortunate victims dragged out into the garden at all hours to look at things. But my daughter, this is Harriet. She's 9, and she decided she wanted us to do a star camp in the garden. So we set the tent up and some telescopes. This was back in May, and we stayed up very late for 2 nights. Took some pictures of the moon, just so you can see that it was a proper star camp, as you see over on the right hand side. There was some beer involved. Harriet would kill me if she knew you were all looking at this picture of her asleep. This was I think this was early on the Sunday morning when she was absolutely spark out, and nothing to do with the beer. She just had a good night observing. This is a picture of the kids in action taking pictures. This is Isaac, my son, who managed to show me up by taking an absolutely tremendous image of the moon with his phone. Pretty typical. There we are. During lockdown, this place has been has been a godsend for me. This is my caravan, which is over in Cumbria, where I've been fortunate enough to spend quite a few clear, dark nights. It's a Bortle Class 3 site, and I'll explain what that means to you as we go through this talk. But it's a nice location. I've been there all weekend, and I'm home now. And unfortunately, it's cloudy here and it's clear over there. But, that's the way it goes, unfortunately. Okay, So, the Milky Way. It's amazing to think that huge numbers of the world's population never get to see this. They don't get to see this the way that it ought to be seen. So, on the right-hand side of the screen here is an image of the galaxy, the Milky Way galaxy, taken with a static camera on a tripod. In fact, I think this is a driven camera. It's a driven camera. You can see the trees on the ground are blurred. That's because the camera taking the picture of the sky was tracking the night sky, which of course makes everything on the ground blurred, but everything in the sky nice and sharp. And what we're looking at here is the light, combined light of millions and millions of stars and dust and gas in our galaxy. Of course, the image over here on the left is what we think our galaxy might look like. This is the Andromeda galaxy, our next door neighbor, but we think the Milky Way is very, very similar to this. You can see some of the features. You can recognize the dark dust lanes in the Andromeda galaxy. We can see them here in our own galaxy. So that's what everybody wants to see, is the Milky Way galaxy like that. The grim reality is most of us live in towns and cities. And this is a map of Europe taken by satellite at night, showing light pollution. We can see us on here. We can see the northeast of England right there, which is sort of lit up like the proverbial Christmas tree. But what we can see just to the left of us is a huge expanse of nice dark sky. So we are quite fortunate that we're so close to dark skies here. But that's not the purpose of tonight. The purpose of tonight's talk is all about, well, what about observing from home? When you've got to observe from home, how do we get the most out of it? So the question, is it a waste of time? Of course it isn't. This would be a very, very quick talk, and it would be over, well, now, really, if the answer to this question was yes, it's a waste of time. It isn't. This is, I think quite a few of us will probably recognize this. This is the car park at Millshield picnic site on the shores of Derwent Reservoir, one of our dark sky sites. How we all wish we were doing this right now, getting together under a clear sky to observe. But for most of us at the moment, this is reality over on the right hand side, and this is an image taken at night from about a mile south of Sunderland city centre. This is Grangetown, for anyone who knows Sunderland. Picture taken at night. That's Don Simpson, Sunderland Astronomical Society's founder, the guy who started the club. This is kind of what we're dealing with. But what I'm going to show you is that there are things we can do, and we can look at observing conditions. We can look at the sky conditions on a given night, and that can help us enormously. We can look at the types of targets that we're actually observing on a given night. We can look at the equipment that we use, the accessories that are available to us. I'm going to spend a bit of time talking about filters for visual observing as well as taking pictures, and finally imaging. We'll touch on that. But as I say, I'm not an imager, I'm a visual observer primarily. But okay. So, you're probably aware light pollution is the biggest thing that we have. It's the biggest enemy that we have as urban astronomers. But it's not the only one. And if you think about it, street lights, how on earth are they affecting the sky? Something must be going on in the atmosphere to reflect the street lights that are shining up, back down again to the ground. And it's water vapor in the atmosphere, as we'll see as we go through the talk. That's the primary thing that we have to contend with. When we go to a nice dark site, the water vapor in the atmosphere is still there. It's just obviously the street lights aren't. But as we can see, certain nights are better than others, and it's useful to be able to know how to know what kind of a night we're actually looking at. I'm going to touch on transparency and seeing, which are two two phrases that some people might have heard of, you might not have heard of them. I'm going to explain what transparency and seeing are, what they're all about, what they're caused by, and what given conditions help us or hinder us from observing. We'll look at some urban heat sources and explain the effect that they can have, and how choosing your observing location very carefully can yield some rewards if you're very patient. Okay, so light pollution, the biggie. Really, what I want to concentrate, because we're living in times where we're moving away now from these kind of old-fashioned orange street lights, the very orangey coloured lights. This is low-pressure sodium street lighting. These were very, very popular until probably 25 years ago. Then they started being replaced by the sort of more bright yellow ones, which is high-pressure sodium. We're now moving to this kind, LED lighting. We're now moving over to a sort of a white light. But the pictures I want you to really look at are the ones at the bottom here. Now, if you look at this picture on the left, you can see the guy is actually standing there, look. So the fella that's here, you can see him nice and clearly on this image on the right. The chap's there. What's different about these two pictures is that on the picture on the left, this light on the side of his shed is angled so that it's pointing towards the camera. And on this image on the right, the light is pointing straight down. So this is an example of direct light pollution. This is the effect that a direct bright light source has when it's in your field of vision. Imagine trying to do astronomy with that shining in your eyes. It's difficult enough trying to do it with all of that reflected white light, but trying to do it with a bright white light source shining in your eyes makes it very, very difficult. So the positioning of lighting is very important. You can kind of see this for yourself. If you go out into the street and stand under one of these very bright LED street lights and look up at a clear sky and just count how many stars you can see, then stick your hand up in front of your face and cover the light and blink it backwards and forwards. So move your hand to cover it and then uncover the light. It's amazing how many more stars you can actually see when you don't have the bright white light source shining in your face. And this is very, very important, as we'll see when we move on. Weather. It's helpful to know a little bit about the weather. Weather forecasts are getting better, although interests, very, very specific interests like astronomy, are not often that well catered for. And it's amazing how many times on TV forecasts and on even the UK's Met Office website, amazing how many times they say it's going to be cloudy tonight and it's not. And it's also amazing how many times they say it's going to be clear and it's not. But it does happen from time to time. I remember speaking to Paul Mooney, Look North's weatherman. He came and he gave a talk to the Society a number of years ago. And I asked him a very specific question about what kind of conditions give us northerly airflows over the UK. Because what I'd noticed over years and years of observing was that some of the best observing conditions were found when we had northerly airflows or northeasterly airflows. And he explained to me that what you're looking for is a high pressure system about here. So a nice high pressure system just south of Iceland to the west of the British Isles here. And what that does is it draws cold air down from the polar regions over us. And if it's clear when it's doing that, it's nice, clear, dry air. It's very, very low water vapor content and it's excellent for observing. Now, the reason I stuck this picture over here with the snowy street, most people wouldn't bother getting their telescopes out when it's snowing. But when the sky, it's not just the sky that's the problem. It's after it stops snowing, quite often after a snowstorm, it'll clear and you'll get really, really lovely, clear, crystal clear sky conditions. Problem is that if you live in the town with the street lights, the snow acts as a perfect mirror to throw a load of light up into the sky. So trying to observe very, very faint objects can be difficult when there's snow on the ground. So be aware of that. Okay, so water vapor content. 2 pictures of the sky. Hopefully you can notice there's a difference there between the colour tone of the sky. So we're in the UK very used to seeing sky that looks like this when it's clear, over on the left, a kind of light turquoise blue colour. That's because predominantly in the UK our weather comes from the west. The prevailing weather comes trundling across the Atlantic, picks up loads of moisture on the way as it passes over us, and our skies tend to look a little bit milky like this. Places in regions like Chile and Arizona in the USA, very dry places, the sky has a much deeper blue colour to it. It contains a lot less water vapour, but occasionally we get those conditions in the UK where the airflow is coming down from the poles. It's coming from Siberia and over the North Pole, and it's very dry, and we do get this nice deep blue. If you see this lovely deep blue colour in the sky during the day, you can kind of expect we're going to have a night sky which is perfect for looking at fuzzy faint objects, if that's what you're interested in looking at. Okay. So transparency and seeing, 2 very different things. Transparency talks about how clear the air is, how transparent it is. It's a measure of basically how much water vapor is in the atmosphere. And we measure transparency using something called the Bortle scale. This is also now used for describing how dark a site is often used for that as well. But primarily the Bortle scale is about transparency. So you will get nights where, well, every day is different, basically. The amount of moisture in the air each day is completely different. The Bortle scale runs from 1 to 9, with 9 being the worst and 1 being the best. Now, seeing is something completely different. Seeing is how much the atmosphere is wobbling. So see with this little image here, we have starlight. We see the light from stars traveling as perfect parallel, unblemished rays of light from the stars across space, and then it encounters the Earth's atmosphere and it just bleh. So what we see as a star on the ground is after the light has passed through our atmosphere, and the atmosphere is boiling and bubbling and moving around in cells that affect our view. And the amount by which the atmosphere is moving each night we call the seeing. There are a couple of different scales for seeing. The 2 most common ones are Pickering and Antoniadi scale. Confusingly, the Pickering scale describes the higher number, the better the conditions. The Antoniadi scale, the lower number signifies better seeing conditions. And that's the one most people tend to use, is the Antoniadi scale. So if it's a seeing scale 1 on the Antoniadi scale, it's nice and steady, the atmosphere, which is perfect for looking at things where you want to see detail. So the interesting thing about this is that on a given night, you might not have both good transparency and good seeing. In fact, it's very, very rare that you would get both, and there's a good reason for this. Good seeing comes from the air being still, not much movement in the air. That tends to promote the formation of mist, so you'll get more sort of misty skies when the seeing is steady. Likewise, when the sky's moving around a lot, you'll tend to get good transparency. Good transparency, a nice clear sky, is good for looking at deep sky objects. So if your interest is looking at galaxies or star clusters or nebulae, what you want is good transparency. So you want a night where the stars are twinkling a bit. You go outside and look up. If the stars are twinkling, that's telling you it's unlikely you're going to get mist forming. So it might be a good night to start looking at those faint deep sky objects. If the stars aren't twinkling at all and the sky is taking on a very, very milky appearance, it's a good night for the planets, because the sky is it's not going to be conducive to deep sky, but planetary observing and imaging, you're going to get nice steady conditions. Okay, so living in towns, one of the things two of the things we have to contend with, we have all kinds of sources of heat from people's central heating systems and chimneys from their fires, and these will interfere with your observing. If you're trying to set your telescope up next to an outlet vent from a gas boiler, or above a chimney that's belting out smoke from a fire, it is going to interfere with your observing. Try and avoid being in an area where you've got a vent, because that will spoil your evening. The other thing that urban areas have is a lot of concrete, is buildings, roads, and indeed locally in our back gardens, it's very tempting to set your telescope tripod up on your patio, on your flagstones or block paving. The trouble with that, particularly kind of August and September, this time of year, is that during the day, those flagstones and block paving will soak up a lot of heat from the sun, and they'll gradually release it all back into the air after it gets dark while you're observing, and this can cause localized heat currents, which can interfere with your view. If you're going to observe or image with a telescope, it's actually better to do it on grass or soil. Do it on a natural surface rather than on your sort of patio. You won't be subjecting yourself to those heat currents. Okay, so observing location. I mentioned earlier on about when you saw the chap standing outside his shed. Try and do this if you're observing from home. Try and do it away from direct sources of light pollution. So we can't obviously get completely away from the street lights, but what we can do is try and put ourselves in a position where they're not shining directly on the place where we're observing. If we have street light shining in our eyes, it's going to be very, very difficult for us to get properly dark adapted. And this is one of the big challenges about observing from home. But I did an experiment a couple of years ago in the back garden here with a 6-inch telescope, and I thought, right, I'm going out and I'm going to get myself properly dark adapted, and it takes a long time to get properly dark adapted. It can take about half an hour for your eyes to properly adjust to the dark. Now, once you are adjusted to the dark, the moment you look at a street light or a light on a neighbouring property, it's going to ruin your dark adaptation, and you're back to square one again. So what you want to try and do is get yourself into a corner of your garden where you can't see these things, and hunker down. And when I went out with this 6-inch telescope, I went out with a step stool about 8 inches high, and I put the tripod down as low as it would go. And I basically used my fence and the hedge to block the light from the neighbouring properties. And I stayed there for a long time, a couple of hours, and I didn't come up. I mean, it must have looked bizarre, me sort of creeping around on the ground around the telescope as I moved from object to object. But I found it actually worked. It allowed me to get properly dark adapted, and what I could see improved compared to what I would normally be able to see when observing from the garden. So if you can keep out of the way of these things, and I'm going to show you a novel solution if you absolutely can't keep out of the way of direct sources of light pollution. The background glow that street lights put on the night sky, we can't get away from. but we can try and get away from the sort of the direct light from the lights themselves. Try and observe things high up in the sky, close to the zenith. The zenith is the point directly above our heads, and that is where we're looking through the thinnest portion of the atmosphere. The lower down we look, we're looking through thicker and thicker atmosphere, and that does have an effect on the amount of light that's passing through the atmosphere from these distant objects. But we look at things high up; they're less affected by light pollution too, and they're less affected by heat from buildings. So try and pick your targets nice and high. Not always possible, but try where you can. And concrete. I've seen this. I've seen the effect of block paving just outside where I'm sitting, putting a telescope up on there and watching the heat currents rise once it gets dark. Okie dokie. So one of the other things we can do is to choose our targets carefully. Is to try and observe things in the sky that are less affected by light pollution. I've got a list of objects here. The planets, fairly obvious. I think most people would know the planets because they're so bright. Light pollution doesn't really affect them. But there are a number of other objects which we can look at as well. Stars, particularly individual stars, are not as affected by light pollution as large groups of stars. So we can look at variable stars and double stars. And we'll look at these things called planetary nebulae as well. So we'll have a look at some of these. So you might be able to see over on the right hand side some images of some of the planets that are visible. These three are all prominent in the early evening sky at the moment: Mars, Jupiter, and Saturn. This also applies to the sun and the moon. Obviously, they're not affected by light pollution, but be aware that heat will have an impact if you're trying to observe the planets. So try and sort of heed the advice what I've said about heat sources if you are interested in observing the planets. The moon, lovely target, and the sun during the day. Again, I find this is more affected by heat sources than anything else. Thermal currents around the telescope can wreak havoc with the solar views as well. Okay, so what about some of the other things? Okay, variable stars. These are interesting. Variable stars are stars that vary in their brightness over time. And some of them do this in a very unpredictable way, and others do it in a very regular way. They're a great target for amateur astronomers. If you ever get really bitten by the astronomy bug and you want to do some real science, this is one area where amateurs really can get involved, is observing variable stars. And what you do is you get given a list of these stars which vary in brightness. And what you do is you compare the brightness of them to stars around them of known brightness on a given night. And over time, we can do these things called light curves, where you can see the intensity of the star's light increasing and decreasing over time. And these things are caused by all kinds of, there's lots of different classes of variable stars. Some of them are eclipsing binary stars, so you have two stars in orbit around each other, and when one star passes in front of the other, you see a dip in the light output. Some of them are very eruptive stars, and they're actually, the variability is intrinsic in the star itself. They are throwing off huge amounts of energy into their outer atmosphere and sort of lighting up at regular intervals. They are absolutely fascinating things to look at, and it's as I say, it's ideally suited to town observing, because these things aren't really that badly affected by light pollution. I have to confess, this is one of my particular favourites classes of object to look at: double stars. Why observe them? Well, they're extremely pretty things to look at, double stars. The colours, particularly if you can get a strong colour contrast, they're really, really pretty things to look at. And what I love about them primarily is you can observe them all year, even when the sky is not properly dark in the height of summer. You can still observe these things. You can observe them in the city where the light pollution is really bad, or from a dark site. They're great things to look at. But again, these are things where amateurs can do some real science, because the only method, believe it or not, that we have for measuring the mass of stars is directly by observing double stars, observing the way that one star orbits around another one. It tells you basically all about the mass of the system. And you can actually calculate the individual masses of the two stars quite easily. And this is done by observing the motion of the stars over time. We look at two things. We look at the separation, which is fairly obvious. That's the amount of distance between the two stars, and something called the position angle, which is essentially taken from north, the angle. If you imagine this is a clock face, the angle that one star has to the other relative to north, that's the position angle. And if we measure those two things, the separation and the position angle over time, we can calculate again a curve, and we can use that to work out how much the stars actually weigh. And it's the only direct method of doing it still. And they're very pretty to look at. Planetary nebulae. Most people don't really consider deep sky objects a good target from towns and suburbs, but these particular objects, they tend to be quite small, and because they're compact, they're also very, very bright. So these things are actually very easy to see from the town. Filters, which I'll touch on shortly, will help with these particular type of objects. They'll help to bring them out. But these are fabulous things, particularly, I mean, if you are into imaging, if you have a telescope with a long focal length, these things are great. If you have a telescope suited to planetary observing, then it's a good telescope for planetary nebula observing as well. The name Planetary Nebula, by the way, nothing to do with planets, other than they got their name because the early astronomers used to think that these things resembled the disks of planets, which I suppose they do. And certainly when you're observing them at the eyepiece, they do often look like small disks, look like the planet Uranus or Neptune. Okay. Bright comets, can't bypass these, particularly this year after what we had over the summer with Comet Neowise. Very bright comets are great targets from the town, as we saw back in July with Neowise. This is trying to remember which comet this is now. This was 2014. It's not Pan-STARRS, but it was around about that time.
Probably McNaught.
I don't know if it was one of the linear comets. No, I'll tell you which one it was. It was Lovejoy. That's which one it was.
Just going to say it looked like Lovejoy.
Named after an antiques dealer. Oh, there we are. And some more comets. These are. This one is Pan-STARRS from 2013, and this one's Comet Holmes from 2007. This one was obvious to the naked eye, even from the town. You kind of went out, looked up, and oh, crikey, what's that? It was a bit like Neowise, but without the tail. But it was very bright. Okie dokie. So equipment-wise, so choose your weapon. What is the perfect telescope for city observing? Well, there are two schools of thought on this one. One is that you should go for the type of telescope that's optimized for the kinds of objects that are least affected. So go for a telescope that's good for observing planets and double stars and planetary nebulae. So what you're looking at there is telescopes which have really good contrast. So they would be things like a refractor or a Maksutov or a Newtonian with a very small secondary mirror. The other school of thought is go for the great big telescope and use filters. Filters tend to respond, as we'll see in a moment, they tend to respond better if you've got a bit more light grasp. Filters don't often work as well for visual with smaller telescopes because the telescope doesn't capture a lot of light. A small telescope doesn't capture a lot of light in the first place. So let's have a look at the two different kinds. So we can get ourselves an enormous refractor and lash it to the top of an old Volvo estate car like this chap's done. So this is basically this is a refracting telescope. So refracting telescopes don't have any central obstruction. They don't have a secondary mirror in the way. So all of the light that the telescope gathers pretty much gets to your eye with no deleterious effect of an obstruction in the way. So these kinds of telescopes will give you very, very good contrast. And a lot of people, even seasoned observers, often remark and can't really get their head around how the view through a small refractor can be as good as through a bigger reflector. And it's all to do with contrast. The detail is actually, the detail's always there in the bigger telescope. It's a weird property. Contrast, you can improve if you're taking pictures. You can improve contrast in post-processing, but you can't do that when you're observing with your eye. So a high contrast telescope will give a high contrast view. This is a Maksutov Newtonian telescope with a very small secondary mirror. You can see the secondary mirror cover there. It's tiny. And again, this type of telescope gives very, very high contrast views. So they're again regarded as good for looking at things like planets and double stars, things where you want a nice clean image. So the other school of thought is get a great big light bucket, a great big reflecting telescope, and stick some filters on so you can filter the light pollution out. And again, I had a fair bit of success with this technique from the town as well. Have been able to see some really, really faint objects, some things that are, traditionally regarded as difficult even from a dark sight. With a large telescope and the right kind of filter, it is possible to see things. Okay, so you might have chosen your weapon. What about the ammunition? Okay, so there's things we can do to make our telescopes respond better in an urban setting. Light pollution filters is certainly one thing that we do. I'm going to spend a little bit of time on those in a moment. Dew shields and light shrouds is another one. Eyepieces, choice of eyepieces, and I've put observatory there for the final thing, but there's other things we can do as well, as we'll see. Okay, so filters. In terms of, this is for visual observing. I'm gonna stick my neck out. I'm gonna kind of say I've never found broadband nebula filters or broadband light pollution filters to work very well. So these are marketed by different companies under different names. So things like the Lumicon Deep Sky filter, or what's the other ones we get? Sort of the CLS filters by lots of manufacturers. I don't tend to find these things work very well. What they try to do, this chart over here kind of shows what the filter is doing. It's trying to filter out where the street lights produce most of their light, whilst still letting through as much of the light from objects in space as possible. So whatever it is you're looking at, a galaxy or a star cluster or nebulae, the idea is that these filters will chop down the light that's coming from artificial light sources and will enhance your view. Now we call this a broadband filter because that's letting through there. That's the pass of the filter. That's how much light and the different wavelengths it's letting through. So the street lights are over here, and the yellow particularly with the old sodium street lighting. But with LED street lighting now, the LED has a big peak here, right where this filter was designed to chop it out. So it's very, very difficult. I find with broadband filters, they don't work particularly well for visual. They work quite well for imaging. If you're taking pictures, then a broadband filter like a CLS filter will improve your chances of capturing things from the town. What's far more interesting and far more useful are so-called narrowband or line filters. So there are a couple of kinds. There's an oxygen 3 filter, which only lets through the light of oxygen, doubly ionized oxygen. Now, why this is useful is because lots of things, particularly certain types of nebulae, and those planetary nebulae we mentioned in the last section are one of these things. They give off quite a lot of light in this part of the spectrum because they're composed of doubly ionized oxygen. That's what the nebula is made of. It's what the cloud is made of, and it's giving off light at this very specific wavelength. So what these filters do is they chop off everything else except a really, really narrow part, which is close to those lines that gas is glowing at. So there's a couple of different kinds. There's oxygen 3 and there's hydrogen beta. And those are the two main, for visual observing, those are the two main nebula lines, hydrogen beta and oxygen 3. Now there's a third kind of narrowband filter called a UHC filter, and they actually pass both of these lines. They're quite close together, by the way, these two lines. They're very, very close together on the spectrum. The oxygen line is in the green, and the hydrogen beta line is also in the green, not to be confused with hydrogen alpha, which is in the red part. Our eyes aren't very sensitive to red light, particularly in very, very low settings. So it's why we don't see things like the Orion Nebula in glorious sort of that pink color we get on photographs, because our eyes just don't pick up the hydrogen alpha emissions. What our eyes pick up is the hydrogen beta, which is slightly fainter, but it's in the green bit where our eyes are most sensitive. So the human eye is more sensitive in this part of the spectrum as well, which is what makes the oxygen 3 hydrogen beta filters so useful. And certainly some objects in the sky are impossible to see without these filters. I would say in a city setting, the oxygen 3 filter is more useful than the hydrogen beta, because even with this very narrow bandpass, I've always found hydrogen beta filters you need dark skies as well, really, to get the most out of a hydrogen beta filter. But an oxygen 3 filter, they work great in the town. I've visually seen the Veil Nebula very easily from the back garden with a 5.5-inch telescope using an oxygen 3 filter, and that's regarded as or used to be regarded as a very, very difficult object to see, even from a dark site if you didn't have a filter. But dead easy with the oxygen 3 filter. Helps to give you a bit more of a chance of seeing things. Okay, what else can we do with our telescopes? Okay, if you have a Dobsonian type telescope, particularly a truss tube like this one, where we have a big gaping open part of the telescope, this poor lady here is not really going to see anything observing here without a light shroud, because there's going to be so much stray light getting into the telescope through here that it's going to make it very, very difficult for her to see anything. So what this chap's doing here is he's wrapping a black plastic shroud around the middle part of the telescope. That's going to cut out any stray light and make the view, well, far more pleasing. One of the other things people do with their telescopes as well is they flock the inside of the tube. Quite often with a reflecting telescope, the tubes, when they come, they're painted usually black, but sometimes they use quite a glossy finish, and you can still get, particularly in town where there's a bit more light around, you can get internal reflections in your telescope just from light bouncing off the side walls of the telescope tube. So what people do is they stick this flat black sort of cloth or paper to the inside of the telescope, and this it dramatically improves contrast, and it helps. It helps, every little helps to get those faint photons into your eye rather than scattered light from something else going into your eye at the same time. Now, another thing you can do is extend the length of your Newtonian's tube. Normally, dew shields are used on the front end of Schmidt-Cassegrains or Maksutov type telescopes with a glass plate at the front, and it's used to stop dew from forming on the front of the telescope. Some people have reported actually sticking this type of this is just camping mat, by the way, sticking this type of sort of elongated dew shield on the front of a Newtonian reflector. It can help cut out stray light as well, and it will actually stop dew forming on your secondary if it's a very, very dewy night. Eyepieces, very important actually. The most important thing is keeping them clean. You can lose a magnitude, that might not mean a lot to some of our beginners, but the more experienced observers will know that losing a magnitude because you've got grease and dirt on your eyepiece, when you're already contending with everything else that the urban setting has to throw at you, you can do without it. So it's important to keep your eyepieces clean. Types of eyepiece, again from the town, I've always found sort of more simple eyepiece designs, ones with fewer elements, seem to work very, very well. So things like Plossels and orthoscopic types of eyepieces work very, very well. There's less elements inside the eyepiece, less air to glass surfaces, less scattering of light.
Graham.
Yeah.
But
Oh, you need to unmute yourself again, Chris. Chris, you need to unmute your mic. You've muted yourself again.
all right, sorry.
There we are.
And I put my hand up. I'm just saying, so you're suggesting it's a good idea not to use the super wide angle, the new generation of super wide angles that seem to be really popular.
I mean, if you've got them, you use them. You use whatever you've got. Keep them clean. But what I've found is that the views I've had from home have actually been better through simple designs. Things like Plossels and orthoscopics with 4 elements. I mean, a lot of these super duper Teleview, Nagler, and Ethos eyepieces have got 7 or 8 elements in them. It's an awful lot of different elements for the light to pass through. Just an observation.
I would tend to agree with you.
Yeah. Okay, not everybody can afford an observatory. If you can, then the obvious benefit of an observatory is chopping out stray light. It means if you're in your dome, peering out through a narrow slit, you can get properly dark adapted in there, and you're not going to have street lights shining at you from all kinds of angles. If you don't have your own observatory, and cracky, most of us don't, go for the solution over on the right-hand side of the screen here, which is to build yourself a portable screen. And these can be made for coppers out of a couple of garden canes and some rubble sacks. And what you do is you build yourself a black screen that you can plug in the garden, plonk it down in your border or the edge of your grass, or lash it to the side of a fence or whatever. And so basically it will blot out the street lights, and you can get behind it, and you can get properly dark adapted, and you'll find it does work. There's absolutely no doubt it does work. Again, it's you know, just doing all these little things really to help yourself as much as you possibly can. Okay, so what can actually be seen? Well, all of these things can be seen from the town. Double cluster, lovely sight. Again, try and observe it when it's at the zenith, when it's right overhead, and it is. We're getting to that time of year, October, November time, particularly. The double cluster is riding right close to the zenith. You know, late evening when we're out observing. Perfect time for it. Likewise with the Andromeda Galaxy, again M31. This time of year, it's riding nice and high. It's a great time to try and spot it. Some planetary nebulae. This is I think this is the blue snowball nebula. You don't tend to see a lot of colour when observing deep sky objects, but planetary nebula, you can often make out the colour, and they do appear bluey greeny through the eyepiece. It's that oxygen and hydrogen beta emission that you're seeing. Orion Nebula, we'll probably have to wait a few more months to see this one in the evening skies. But again, it's a great sight, even from an urban location. And a couple of tricky ones. This is Hubble's Variable Nebula, which I have seen from my back garden. So this is a winter object as well. This is in the constellation of Monoceros, the unicorn. And the Veil Nebula, this is the Witch's Broom. Again, I've seen this from the garden, but you do need a filter. You do need one of those oxygen 3 filters to be able to spot this. So those narrowband filters I talked about, they don't work particularly well on clusters or galaxies. And the reason for that is that clusters and galaxies are made of stars of lots of different colours, and they're emitting light over a very, very broad part of the spectrum. So filters, all they do is they cut the light pollution out, but they also cut out a lot of important light from the galaxies and the clusters. So the things that you're going to observe with filters are nebulae, gas clouds. That's what the filters are useful for. Okie dokie. So what about imaging? Imaging the sky is incredibly popular now, and why not? the stuff that's available to us now is absolutely incredible. For your targets, obviously the planets are not going to be affected by light pollution from the urban setting. If you're going to image deep sky objects, certain types of objects are best done from a dark site, but others quite happy doing it from the town with the right kind of filter. So broadband light pollution filters, those things that I said, well, they don't really work that well visually. If you want to take pictures of galaxies and pictures of star clusters, then some of those filters are very, very, very helpful indeed. So imaging the planets. This is my solar system. This is the whole of our solar system imaged from Washington. Took me 2 hours to assemble. 2 years to assemble this image. Took me 2 years to get all of the individual planets, and stuck a little image of the moon in where the Earth should go, because I can't image the Earth at the moment. So if you are wanting to image deep sky targets, these kinds of filters are very useful. So these are popular ones. This is the Astronomy CLS filter, and a couple of IDAS filters. This is the P2 and D1 filter by IDAS. These are good. I should also add that there's another very good one from the Chinese company Optolong, which is cheaper than all of these, and works better as well. So the Optolong L Pro is a very, very good filter if you are wanting to take pictures of a wide range of different things from the town. And these filters will allow you to take exposures of 2 to 3 minutes with minimal light pollution effects. If you want to image nebulae, so you remember those gas clouds, those targets which are very, very good for filters for visual, these type of objects are also, there are filters available for these, for imaging them from the town, and these are very, very narrow band filters. So hydrogen alpha, oxygen 3 being the two important lines again for nebulae, and the results that you get from the town with those filters are every bit as good from a dark site. If you're imaging nebulae, narrow band filters will allow you to take some pretty stonking pictures, as we see here. So image on the left, this is the Elephant's Trunk Nebula. This is one of Paul Jenkins' images. He took this from his back garden in Newton Aycliffe, down near Darlington, through narrow band filters. And the image on the right is the Horsehead and Flame Nebulae in Orion, taken by Ian Aiken from his garden in Fulwell in Sunderland. So again, you can kind of see what it's possible to do from an urban, not even an urban, virtually city centre back garden with the right kind of equipment. And of course, if all else fails, you can just stay in and Mr. What's his name again? Mr. Cowell will provide you with alternative forms of entertainment. But frankly, I'd rather be outside under a cloudy sky myself. But there we are. But thank you very much for listening. If anybody has any questions, I will certainly try and answer those. I'll stop sharing that now so we can get everybody back.